Hello, everybody, and welcome to the Friday, February 24th edition of Forensic Friday. This week, we are going to be hearing about VLAN and how it can be used for hacking and cybersecurity purposes. Um, I will pass it off to, I think, Alex, you are up first, so I'll pass it off to you. You can introduce yourself and get us going.
Yeah, thank you. So my name is Alexander Medvednikov. I'm the creator of the V language. Um, I live in the Netherlands and I've been working on it for a couple of years now. This is a very new, exciting language that takes a lot of new approaches. So why create a new language? This is probably the first question that I have to ask because there's thousands and thousands of different languages already out there. Our main logo is it's a simple, fast, safe, compiled language for developing maintainable software. And these are the most important points about this language. So it's basically a language that is as simple and readable as Go, but it also provides the performance of C, C++, and then the modern features of languages like Rust and Kotlin and Swift, things like sum types and result types and nice error handling and so on, so on. So let's go through all these cool features one by one. So yeah, first of all, it's simple. As it says, it's like the very first adjective we use. This is the most important thing about this language, and simplicity. It is indeed beautiful, and unfortunately, these days, modern software, it's not really simple, and the languages they do not really help you build simple and maintainable software. So V really embraces this keep it simple principle. So yeah, it's great for prototyping. It's also great for building stuff quickly, and it's great for making it maintainable. So 10 years later, you come back to your code base and you can figure out what's going on. So kind of like with Go. So each code base is very similar because there's only one style. Mostly there's only one way of doing everything. So yeah, this makes things easy to maintain and understand. So yeah, other features, compilation time. It's very fast. So kind of like Go, but unlike most other modern languages. And since V is written in V, we can use this simple demo to demonstrate the compilation speed of the compiler. So I'm in the V repo right now, and we can verify with SSC. It's kind of like a faster alternative to clock for measuring lines of code. And yeah, the repo is almost 300,000 lines of V at this point. Of course, not all of it is the compiler. The compiler itself is about 100K. And yeah, we can run time V, show v2, cmdv, that compiles the entire V compiler. And as you can see, it takes 0.45 seconds. And we can verify that we actually have a V compiler compiled by running this v2 binary. It has a REPL, so that's also nice for a compiled language. And it works. So this is really, really nice, again, for prototyping, for building stuff quickly. But we also have Hotcode reloading, which makes developing even faster. Because yeah, the compilation is fast, but sometimes you are developing some complicated system and you cannot afford losing all the state and then getting back to the state like in a game or some other complex project. So we do have that. There's an official examples directory which has hot reload examples, and the coolest one I think is the bounce example. Oops, I just compiled it, I want to run it. So yeah, we have a bunch of 3 squares just jumping around, and we can open the let's have the actual program over here, and next to it we'll have the running program. So yeah, this is the entire program, very simple. So we can increase the speed, for example. Just hit save. It takes 1 or 2 seconds, and then you can see immediately the speed is increased without recompiling. I can change the color of the rectangles from black to blue, and I can make it slower again. So yeah, that's how it works. It had some limitations, of course. You have to mark the functions with the live attribute, and right now it's not possible to reload types, instructs, and all that. But we're working on it, so it's going to be really cool for hacking something, without losing the state of the compiling stuff. C2E translation. So V, it's V and C, they're very close friends. And actually, one of the main reasons I created V is I used to be a Go developer, and I was building this project in Go, and I had to I had to use a certain C library for performance, and because there was no other library to use, there was no Go library to use, and then you have to use C to Go. So what's it called? CGO. Yeah, you have to use CGO for that. And there are two problems: it's slow, and it's almost impossible to debug. Because Go has its own runtime, and yeah, it was so annoying that I ended up just writing a simple language that translated to C in 2 weeks, because I hated C++ and I didn't want to write it in C in the 21st century. I needed strings and arrays and all that. So it was very simple, and it was not supposed to be public. But then I posted a comment on Hacker News, I think. People got interested, and then I had to make it public, create a website, and then eventually release the entire language as open source. So yeah, Go and C, V and C are very close friends. V can compile to C, it's one of the backends. It can also compile to JS and Go and the native backend, but C is our primary backend because it gives us the optimization offered by the Clang and GCC compilers. But we also have another thing, the opposite direction. We can translate C to V, and that gives us two things. First, we can reuse existing C code without spending time to rewrite it, and that's millions and millions of potential projects. And then we can also write wrappers. So, for example, we have some big C library that we cannot translate or we don't want to translate, like OpenSSL, for example, which has thousands of functions. And then we can use C2V to generate nice V wrappers. And then it's super easy to call C libraries from V. And a really cool thing we have is that we have the entire Doom, the original Doom, 93, translated, compiled, and run in V. So let's do that real quick. There is a GitHub vline /doom repo, which has all the code. So we just clone this. It has the original Chocolate Doom C code, and then all the translated V code. So here's how it looks, for example. This is legit V code, nicely formatted. So let's see how quickly we can and easily we can generate this stuff. So I just go to the Doom repo, and there is a nice build hope project script. We can just run it, and while it's running, we can have a look what's inside. So CDV doesn't understand makefiles yet, so it can only translate simple C files and then compile object files, and then you have to link them manually. So that's a bit inconvenient, and of course we're going to fix this by the time it reaches 1.0. So it's done. Let's have a look. It basically looks up the Doom WAD file, which contains all the music and textures and all that. So yeah, first we build chocolate Doom just to generate all the other C stuff that's not translated. And then we translate the actual chocolate Doom / Doom directory. And then, yeah, we compile it with V, and we tell V to generate the doom.o object, and then we just link it all together. This is the doom.o that we translated, and then all the other stuff that's required to build Doom, and then we just run it. And the result is this. Oh, it's going to work with the recording thing. And as you can see, there are slight visual bugs, like at the bottom, there is some messed up menu. I think you can fix it by... Okay, you cannot fix it, looks like. But yeah, it's really minor because the game itself, it runs great. There's sound, there's AI, there's shooting, there's walking, there's all that. So this is really cool because this is tens of thousands of lines of C code translated to V, and this demonstrates how easy it is to, uh, make your C code work with V. So yeah, C interop is a first-class citizen here, like it says on the website. One of the main features compared to Go, because yeah, like it says, V is basically 80% Go, and here's a very nice list of the stuff that V improves upon Go. So improved error checks, C interop I just mentioned, GC is optional, so this makes it nice for low-level stuff like kernels and drivers. You can just disable GC. And either use auto-free or just manage memory manually. No global state. This is kind of a revolutionary feature, but you can enable them for low-level stuff, again, for drivers and kernels. But your default V compiler will refuse to have globals in your application, which promotes better code and safer code in terms of threading and all that. Well, as I mentioned, it has nice features like sum types, string interpolations, mesh expressions, enums, immutability by default, something that Go lacks, etc., etc., etc. So yeah, what's next? The VUI. So yeah, V can be used in very in a large amount of different domains. You can do it for hacking, low-level stuff, drivers, kernels. You can also do web stuff. We'll cover that. You can do UI stuff with the official UI library, which is also MIT. So can be used by anything for anything, by anyone for anything. So let's have a quick look. We actually have like more than 100 examples, but I'm just going to run a simple one. By the way, you can install it with a simple v-install UI. We have our own package manager called VPM. It's that simple and quick. And then let's just go there and run the user's example. I probably shouldn't. Yeah, it works. Nice. Okay. So this is how the UI looks like. It's we have text boxes, checkboxes, and radio buttons, and simple buttons, and this is a canvas for drawing. This is a progress bar. This is not native, so this doesn't use like macOS, Cocoa stuff. It's all rendered like Qt and similar frameworks like Flutter. But it's made to look as close to the native controls as possible. So this is pretty nice. And yeah, there's in the examples directory, there's lots and lots of different examples. There's, of course, the calculator and more complicated multi-window examples. I'm not going to spend time of them, but yeah. Graphics. Yeah, we do have a built-in graphics library called GG. It can do 2D graphics for now, but 3D graphics is also planned. Again, lots of examples. I'm gonna run my favorite, Tetris. Yeah, so you can write simple 2D games in V. It's all built in. You don't need to install anything. It's officially supported, and it's one of our main philosophies also that the standard library is supposed to be big and helpful and include lots of stuff like in Python and Go. So you don't have to make the complicated decision, which library do I use? For some stuff like JSON, for example, in some languages, there is like maybe 10 different libraries and all the pros and cons. But in V, JSON, graphics, web, and even database access, it's all part of the package. It's all officially supported. I think that's really, really nice. You don't have to spend time on that. So speaking of databases, we have an official ORM for accessing stuff from databases. We officially support SQLite, Postgres, and MySQL. And some people are also working on a Microsoft Server driver as well. And to demonstrate, we actually have yeah, let's do these two, databases and web, because yeah, you can build web stuff as well. And we do have a nice big web app as an example. It's called Gitly. It's basically an alternative to GitHub, GitLab, all that, but it's open source, it's free, it's fast, it's very, very fast. Like, as you can see, you can just pages open up immediately, because again, it's all the back end of it all. It's all compiled to C and then built with the -02 optimizations and lots of other stuff. So it's really blazing fast. And yeah, it's syntax highlighting. It's basically a fully working GitHub alternative. We are launching the beta, an open beta for this actually. So this week. So people can start using either the official Gitly org, or they can host it on their own hardware. And as the website says, since it's so light and fast, you actually need just a small, cheap instance that costs a couple of bucks, and you only need like 100 or 200 megabytes of RAM, unlike other solutions. And just to show you how it actually works, here's a simple, I hope the font is big enough. Here's a simple VWeb application, and you can just run it like this. We run sample. It's already running somewhere. The port is taken. Yeah, this one. So yeah. And yeah, it's a simple text page that demonstrates some basic stuff about the templates. And the unique feature of this is if we go to this editor, by the way, it's called VED. It's also written V. This is my personal editor I wrote for. It's like similar to Vim, but it's a bit nicer. If we go to VWeb examples, so it uses simple templating. You can see it in all frameworks. But a really cool, unique feature is that, for example, in this section, the index, we define these variables show and hello in numbers, and we don't need to send them in any way. They are automatically, they appear here. So that saves a lot of typing and just makes code a lot more readable and nicer. And as for Gitly, here's the Gitly repo. I want to show you the database stuff. So yeah, we have some actions here, like which one do I want to use? User repos, yeah, find user public repos. And yeah, this is how the ORM syntax works. So we just do return SQL, and then we just do select from issue where author ID is user ID and it is pull request equals false. So this is just basic V syntax that you use to construct actual SQL queries. And you write it once and you can use it with Postgres, with SQLite, with MySQL. So this is pretty cool. V has a built-in SQL support, and this is something that some people criticize. Like they think that many people say that some people say that SQL does not belong in a language, but I think in most applications, especially web applications, like 95% of your applications are going to require access to some SQLite database or some other database, and then having this kind of stuff is really, really useful. And again, you don't have to rely on some third-party library for your database stuff, and you don't have to choose. So that's pretty cool. What else? Yeah, some minor stuff. VSH, basically a nice, safe, typed cross-platform alternative to Bash. So Bash doesn't run on Windows, for example. VSH, it's basically a V script with some nice additions. We have some this git recommit hook, for example, we use it for a repo. The only difference that VSH between VSH and V is that you don't have to import OS, and you don't have to define the fn main function. You can just write stuff immediately, like you would do in a Perl or in a Bash script, and that just saves you some time. And yeah, it's just basically a nice alternative to Bash, because when your Bash script grows to becomes longer than like 50 lines, you want to rewrite it in Python or something more usable. And yeah, in this case, you can use V for everything. You can use it for your backend code. You can translate V to JavaScript and use it on your front end, and then you can do DevOps stuff in V as well. So yeah, that was the demo. And let's see if I missed anything else. I think I've covered pretty much the main features. Fast compilation, performance, easy to build, compiler, C translation, Hotcode reloading, graphics. Yeah, cross compilation is also easy. Just do v-os Windows, v-os Linux, and yeah, deployments. Also something that every compiler language gives you. You build your stuff with v-dot. There is no make files. There is no cmake or configuration or anything. Just like in Go, you just run v-dot, you get a single binary, and you deploy it to your server or wherever, and you're done. Very simple. So yeah, I think that's it. If you have any questions, I'll be happy to answer. And yeah, just one more little thing. There is an operating system, a kernel/operating system called Linux, which can already run stuff like text editors, and it can even run a modified Doom. There's a demo on our YouTube channel, so that's also pretty good, pretty cool, and something. Oh yeah, and you can even compile C++ on it already. So GCC runs as well. This is something we're really excited about, and I think this could even potentially be bigger than V in the future, because yeah, all modern operating systems are getting more and more clumsy and bulky and huge and slow. And Linux is pretty much always going to be compiled in a couple of seconds. And I think that's really cool for an operating system. And of course, it's going to be very fast and light, use minimal amount of resources and all that. So yeah, that's it. If